infrastructure. That's essentially the structure that all the different .NET languages need to conform to. It's a series of libraries as well as primitive types and so forth that are meant to be used by all different languages. And because you're using them in each language, that's the reason why the different languages can be interoperable. They can be used in each other. They get compiled down to the CIL, the Common Intermediate Language, which is the equivalent of Java's bytecode. So this CIL isn't quite machine language. It's one level up, but it's also one level below normal programming language. So it goes from programming language down to CIL, and then it gets taken from there and run on the virtual machine. Virtual machine, in essence, turns into bytecode, kind of. But this is bytecode inside Java and CIL inside .NET. So the equivalent of the Java virtual machine for .NET is a CLR, the Common Language Runtime. Essentially, this is where the magic happens that lets you run the different languages on the same object. So pretty much, even though they're different languages, you got J#, you got C#, and so forth. Though they're different, they can all be run on the same virtual machine, which is the CLR. So this pretty much let's do all the magic stuff we've been talking about. So it's kind of interesting how this worked out in terms of comparing Java and .NET. So Java was originally a single language on multiple platforms. You had the Java language, but it could run through the Java Virtual Machine customized for each different platform. So you'd have a Java Virtual Machine for Mac OS X. You have a Java Virtual Machine for Windows. So even though each platform, each operating system had separate needs, the Java Virtual Machine was designed to be run on each one of them. And then the bytecode that the Java compiled to can be run for each platform. So the .NET started out kind of the opposite. Multiple languages on a single platform. So you have your J#, you have your C#, it all comes down to the CLR and runs there. But in reality, it's kind of turned a little bit on the side. Java, because it has an open source policy towards its stack, towards the Java virtual machine and so forth, people found it easy to make their own languages that run on the Java virtual machine. So you have your scalas, you have your closures, you have all these fun things that people have made on their own, saying, hey, this is a really cool idea. I want to be able to use Java virtual machine, have my code run on any platform. Therefore, I'm just going to make my own language, and it'll go be a JVM language. So like I said, C# kind of started that whole idea in mind. But in reality, despite the fact that there's stuff like Visual Basic and J# and a number of other ones that people have done individually, for the most part, it hasn't really been very easy to do because of the proprietary policies of Microsoft. So in essence, really, there's C# on .NET. So the language of C#, it kind of started as a Java clone. It was very similar inside the original version of it. First came out, .NET and C# both came out in about 2001 or so. Java and C# are both object-oriented. They're both statically typed. They're both class-oriented. And they have a lot of similarities in terms of how they actually look as well. Actually, one other thing. So an interesting thing about C#, it was actually standardized, I think about 2004. But the thing is, since then, Microsoft has really expanded exactly what C# is, but the standard has not followed along. So a lot of stuff that's happened in C# since it was standardized have kind of been Microsoft proprietary. But recently, a few months ago, Microsoft opened up the .NET framework stack to be open source, as well as making more license abilities towards creating your own C# utilizations. So it's kind of changing a little bit. So, but things that were later added to C# that are non-Java are stuff that have come to Java more recently, but have been in C# longer. A lot of functional aspects, such as lambdas, first-class functions, and LINQ. LINQ is kind of equivalent to stream inside Java. I don't have an example of it. It looks like SQL, except you have the select at the end. So pretty much it lets you start with some collection, some sort of list or whatnot, some sort of series of values or objects, and process them sequentially through a pipeline. So you start with a list, then you do one operation, do another operation, do another operation, and you say what you want at the end. So that's LINQ, is similar to stream inside Java. Lambdas and first-class functions. First-class functions means that you can treat functions as variables. So you can pass them around and do things like that. Lambdas are just anonymous functions, basically. Other things that have been added to C# are advanced method argument abilities like defaults and optional variables, name parameters. I should really have examples of stuff so it's more than just words. So here's an example. Here is hello world, or how's it going world. You can see this is very similar to Java. You got your class, you got your main function, static void main that has a series of arguments for arguments. And then you say system console print line, how's it going? And then it takes it out and prints out to the screen.
You can scroll that, by the way.
Oh, I can?
Yeah.
Oh, cool, cool. So here's a slightly more complicated example. It uses first-class functions as well as delegates. Delegates, first-class functions, and generics. So right here, where it says public delegate, this T that's used in these three places, that's kind of like a variable type. So that type that's used in the argument inside for any function that is used as a transform is going to return the same type. So this is saying it's a type of a function. So a transformer function that takes an argument T and returns T, where T is the same thing. And you can see it being used right here inside this utility function, transform, where it takes a transformer function and uses it. Oh, this is an earlier copy. Oh. Well, T is a function right here, and it gets called right here. So you pass in the first-class function T, and you're using it right there. And also, one thing to notice is that, like the delegate, using generics to say this is a type is used in all three places. Whoops. Where it's the array that's passed in as well as the type of the transformer. So kind of the where it gets used, as you can see, so here's the delegate. So you say you have expecting a function that takes the same argument as return value. And you can see right here that exactly is what's happening. You have a square function and a substring function. The square function takes an integer argument and returns an integer value, just x times x. Substring takes a string x and returns a string, just taking a substring, taking the first four characters of what's passed in. And you actually see it being used right here because this is a Mac we're using. I'm not actually writing the code. I'm just going to kind of show you what it does. So here you have an array of integers, 1, 2, 3. So util transform was this guy right here. Transform takes a function, an array of integers, an array of values, I say same type. Here you have an array of integers, pass in there to the same method, and you take a function that takes an integer for argument and turns into an integer. That's passed in right there. And that transforms the array into 149 from 123. And the same thing happens right below with a series of strings. Here now some knowledge, what worry turns into here somewhat. And the important thing to notice is that the same method is being used both times. Util transform is being used in both places, but what's happening differently is you're passing in a different first-class function. The squares from up here is being passed in the first one, and the substring from right here is being passed in the second one, which makes the method you pass it into act differently. Let's see. Okay, I have a short presentation. Closure.
Thank you.
Let me just do a speck of bookkeeping here. Sorry.
Grab my hat. Were you able to get a light table?
Yeah, I did actually.
Oh, cool.
I don't know if that's gonna work out. So we got to move on. So I'll get you your slides. But yes, light table is on here, and here is, let's see, this is here. So I think you just type in light table, or do you pull it up like this?
I pulled it up like that. Yeah.
And actually, it's probably going to be the only thing in it, right? So you can go to open recent; it'll be in there.
All right.
Or blue screen.
Yeah. Oh, shoot! Hold on a second.
Oh no! I need power. That's probably why.
Go steal yours. We're good. And sorry, man. Of course, it happens now. Computer setting up image. Yeah, I bumped it. There's somebody who threw some coupons here. Bumped it. Not there either. So, do you want me to go slides or just go straight here?
I just want to get that started, and then I'll switch to slides.
Okay, you're good. So, actually, to switch to slides, just so you know. Okay, go into Chrome and Command Shift F get you there, right?
Okay.
And to get out of there, well, try it a few times maybe. Come on. Darn you, Google. So Command Shift F gets you out, and then it's just a Mac.
Okay.
So you're good. So maybe 5 minutes, Tristan.
5 minutes?
Yeah, we got. I wanted to do a QA afterwards, so as fast as you can. Let's put it that way.
Can I do 5 minutes? All right, Clojure. Clojure is a modern Lisp that runs on the JVM as well as the .NET platform as well as JavaScript land. So anywhere that Java runs, Clojure can run. Anywhere that C# or .NET runs, Clojure can run. Anywhere that JavaScript runs, Clojure can run. There's a very strong focus on simplicity and concurrency. It's mostly immutable and it's mostly functional. It has basically everything else in it. It comes from the Lisp lineage of programming languages, so it's a bit different. Lisp is one of the oldest programming languages that's still being used. It was invented in 1958. Has strong dynamic types, macros, multi-methods, several decades of really cool stuff. It has access to all the Java libraries. You can use any of them if you're running on the JVM. It has access to all the .NET libraries, so you can use any of those libraries. It has access to all the JavaScript libraries because it's everywhere. If you want static types, there's a library that adds that. If you want pattern matching, there's a library that adds that. If you want logic programming or other concurrency constructs, there's libraries for all those too. It has a REPL, like most of the languages we've talked about. But it's a bit more than others because it allows you to interact with and even build programs while they're running, which is what I really want to focus on because it's different than anything else I've seen. So I have Light Table. It's an editor and a REPL.
It's not too bad, but if you can blow it up at all, make the font bigger.
Yeah, just,
I can read it where I'm at, but the back probably a little tougher. Okay, yeah, that's fine.
okay, so I have this program. This is what Lisp and Clojure code looks like. So if you notice, everything starts with an open paren, and then you have a function name, and then some other stuff, and then a closed paren. Everything does that. If you want to call a function, if you want to define a function, if you want to do an if statement, if you want to import something, it's all the same syntax, which is really cool and one of the things that makes Lisp. So, all right, here's the program. You can barely see it, but that's okay. I'll show you why in a second. This is about 180 lines of code. And like I said, with Clojure, it's really easy to modify code as it's running. So I can come over here where I have some data about these different dots. So if you can see them, there's these red ones that chase others around. I guess you can't see it. But I can go in here and I can change data about that. So right now they have a size of 4. I can change that to like 20. And then I command enter. And when I switch back, they've been changed, which is not something that you see in most programming languages. Most programming languages, you'd have to close it. You'd have to go to your text file. You'd make your change. You recompile it. You restart it. You click around to get back to where you were. It's a whole hassle, but it's very easy. So I'm going to make all these bigger so you can see them.
This workspace is backed by a text file, though, right?
Yes, it is. So
it's not a binary image, and it's an actual program text file.
Right. So at any time, I could close this and I could come back later and it would still be there. And you can, compile it down to jars or DLLs or whatever you're running on and distribute those.
File to go in source control, you don't have a binary like a small talk or
right. Anyway, moving on. So what's happening is each one of these dots, how it works is they are looking at their neighbors and they decide how attracted they are to it. So if it's a positive number, they move towards it. If it's a negative number, they move away. So you can see the red ones are attracted to everything because they're chasing them around. And everyone is repelled by the red ones. And then the green ones are attracted to each other, but not too much. And the yellow ones are attracted to each other, but not too much. So you saw that I can go in and I can change the data, but I can also find the function where it calculates how attracted they are to each other. So you can see here, the plain ones are attracted to the predator -500. They really don't like them. That's why they run away. Whereas attracted to others of their same kind, the distance -20. So if the distance is great, like 25, 25 minus 20 is 5, so they move towards it. If it's small, like 10, 10 minus 20 is -10, so they move away. So that's a very quick explanation. But I can go in and I can change this. This is code. I can change it to something else. And then when I switch back, now they form smaller clumps. Or I could change it to something like this, and now they run away from each other. And they try to space themselves out. So the point of that is that you can go in and you can change code while it's running, and you can really play with it, and you can experiment with it, and you can iterate on it very quickly. And you can even go in and you can add new code. So I'm going to run this right here, which you can see it does stuff with when the mouse moves and when the mouse exits. And now when I move the mouse, it will put a dot there. And if you go up here, you can see it's a cursor. That's the type of this dot. And the predator ones don't like the cursors. Everyone else kind of ignores it. So if you go over here, you can see that you can chase away the red dots now. You bully them around. So you can also add functionality. You can add new code and new functions to existing code. And then if I don't want that, I can scroll down and replace it with a function that has the same name, but it doesn't do anything. So that effectively just got rid of the code that was running. So it's really, really nice to be able to change code like this because, like I said, you can play with it and iterate on it. And it can be used to make little programs like this, or you can make web apps or big data apps, analytics. My favorite story of Lisps and using REPLs is JPL at NASA was using it in the 90s, and they had this piece of hardware that they sent out to space, and it was $100 million, and it was 100 million miles from Earth, and it stopped working. But they had written it in Lisp, so they were able to connect a REPL to it, and from Earth, they were able to debug it, and they found that it was a concurrency bug, and they were able to fix it, and it began working again, and it completed its mission successfully, and that team won the NASA Software of the Year award. So that's Clojure. It's really fun, really easy to play with and get started. I'm using Lighttable. That's the easiest way to get started. I think it's at lighttable.com. And like I said, it runs anywhere and you can do anything with it. So give it a try. That was 6 minutes.
That was awesome. Very good.
So I don't know if I can beat Python or Ruby earlier on the print line statement, but let's see if I can beat 6 minutes. So a lot of these languages have little niches if you're new to programming and you're wondering, like, you know, what are all these different languages? Tim mentioned culture earlier.
Hey, you want to hit the space bar? Sorry, Tom.
Oh, we want to talk
This
about
is
my
Tom
talk.
Parker, by the way.
I'm not doing demo.
This
I'm
is
doing.
Tom Parker talking about Groovy.
And so each of these languages kind of fit into a niche, and depending on what language you may want to play around with, there are certain places that you can get jobs like Java and .NET or in the big business world, a lot of corporate stuff. Clojure that we saw is really cool. To me, it's a new language, even though it's one of the oldest, just because it's getting a breath of fresh air. It's coming around a little bit. So depending on what you program in, set your environment. Like Ruby is in some really cool shops, sometimes hipster, if you're familiar with that term, is associated with it. But as you guys are experimenting with languages, just kind of keep in mind like what it is you want to do. Some are scientific based, some are business based, some are corporate, whatnot. And there's money in certain ones. Other ones are more, you know, for your interest and whatnot. So I come from a Java background mostly, and so we talked about Java earlier. So we're going to kind of do Java redo on my talk, and we're going to make Java groovy. As we saw earlier, we saw Python and Ruby do the simple hello world, and then we got to the Java one, and something bad happened. We had brackets. It just kind of exploded. It's like, oh wow, what's all that code? You know, kind of hurt my eyes a little bit. So we're going to make it a little bit more groovy. Ruby is a language. You've heard this from a couple different languages, that there's this thing called a VM that runs with some other stuff on top of it. You heard that with C# and with Java. The code runs on the machine in a in you know, ones and zeros, but the language gets compiled down to that, and it gets run, and to make it compatible across different machines, there's like this little layer, like a little machine that runs in there, and it runs certain kind of code. So when you compile Java or some of the other languages, you compile it down and it gets executed, and that's what everybody had in mind. But theoretically, you could do this. You could write a language in many different, you can create your own language and then have that compile down to the same code. So that's what Groovy is. It's like a different version of Java, Clojure, some of these other languages, Scala, kind of run on this principle. It's really neat. It's really cool. If you're not familiar with it, to kind of, you know, sit down, kind of look at it. So I'm going to blow through this as quick as I can, show you a little bit of code. So what is it? Like the other ones, it's basically Java. It's not supercharged, but it's an easier Java. It's dynamic, like a lot of the other languages, Python and Ruby. Some people are afraid of that. They say it's slow or it's this, that, you lose some type stuff. So you can do static, which means you write everything. It's like a book. You write it down before you run it, and it's just whatever you write is what it is. And when you execute it, you get what you wrote. Dynamic lets you kind of play around with it at runtime. The only analogy I can come up with is like the choose your own adventure books. It's a little bit, you can change it on the fly a little bit. I don't know, bad analogies. But anyways, it runs on the JVM. It's inspired by a couple of the programs we talked about earlier, Ruby and Python in particular. Smalltalk is really cool. We're not talking about it tonight, but it's a really cool language. It kind of started this whole boutique languages and best practices and stuff like that. And it's just a library. So you need Java to run it, and it runs as a library with Java. So why would I use it? Basically, most of this is about simplification. It makes your Java much easier to run. It focuses on the domain over the syntax. So you'll see a couple of examples, but instead of all that craziness that we saw, we want to get it back more like the dynamic languages like Ruby and Python, where you're focused on the domain. You don't care about the computer stuff. The computer needs to see certain things like the braces and brackets and semicolons. Well, smart people figured out, well, you really don't need that. The computer's smart enough, it can figure it out with a few rules. And so you focus on what it is you want to write. We saw Tristan showed the little balls that were floating around. You want to write code about the balls, not about computer things. You don't want to see ones and zeros. You don't want to see cruft. You don't want to see things around the code. They have nothing to do with those balls that are flying around. So this allows that. It's portable. It runs wherever Java is. So if you have Java, you can run it. Where can you run Java? Just about any place. So within the code, you'll see it. It's not usually used on its own. You can create your own apps in Groovy, but it's probably a little less common to do that. So usually it plays a supporting role. DSLs, we talked about that with testing earlier. DSL, really hard to explain in just a couple seconds, but it's a mini language. It's like, I don't know. You speak English, but if you're part of a club, you might have your little special terms that you refer to people with. I don't know, that might be like a DSL. It's like a little sub group. It's only relevant where it's actually used, but it's a simple way of doing some programming stuff. Bad analogy. It's used in scripting. So like if you need to do stuff, you need to go cause some work on your computer, like you need to compile some files, you need to reach out to the internet and go do something, pull something down, mangle the text a little bit, push it over here. So it's like stuff that you would do on the computer, not necessarily in a program necessarily. So it's really good in scripting. So people that work on computers, DevOps, whatnot, they probably wouldn't use it, but that might be a place that they would use it. More programmers would use it for their internal DevOps stuff. Supporting roles, testing in Gradle. We saw with Ruby, we saw Spock or RSpec used, and this was for the DSL for the testing over there. Well, it fills a similar role. You can use it for testing your code. You can use it for package management. So you've heard the term dependencies a lot, or libraries. Those are things that your code needs to run, and somehow you have to manage that. You have to either go physically get it off of some device, or more commonly now, you would connect to the internet and you would download it. And this tool called Gradle will do that for you, and that's written in Groovy. Web development, there's Ruby and Rails. We got Groovy and Grails. So you can create your apps using this framework called Grails, which runs with Groovy up under the covers. You can write standalone apps, not as common, but they're there. It gives you some syntax. I'll just blow through this, but it makes Java easier, and these are some of the ways that it makes it easier. Key features and concepts, we've talked around some of these. Closures are a big thing. Java's just getting them. Closures had it. So to make Java better, Java doesn't have a lot of the really cool tools that these other languages do. Well, we just groovified it, made it groovy. So now we've got a lot of these tools. Really neat. Closures, just fancy, not really just, but you can think of them as fancy methods that you can kind of move about. You can do some really neat stuff.
Callbacks without the ceremony.
Yeah. Metaprogramming, you can do things to the program. You can add code on the fly. If you don't like what your number class is doing, you can change what numbers do. Don't do that. You can do a bunch of really neat stuff. You can change things on the fly. We'll just call the next one Groovy Strings and leave it at that. But they give you some really cool if you program, you're dealing with strings. They're vital to what you do, and sometimes the normal string interface that you have is a little bit lame, and depending on what language, it's a little bit better and whatnot. So Groovy gives you some really kind of powerful tools for strings, which is really cool. Duck typing. So in languages like we saw earlier with C# and Java in particular, that you have to kind of declare your types. In Java or in the dynamic languages, they use duck typing. If it walks like a duck, if it sounds like a duck, or quacks like a duck, then it's a duck. If something behaves, looks like, and acts like something, then you can treat it as that. It doesn't have to be a type. Little esoteric, but as you get into programming, it'll be, it's kind of a neat, cool thing. So you don't have to, rely on just doing special coding stuff. It kind of frees you up a little bit. So I've been blabbering for a little bit, so let's go kind of see what this looks like. Where's Steve? Where's the Groovy file?
It's already open in a tab for you, so it should be the next tab. What happened? There we go. Groovy. So it's right in there.
Yes. You have a Groovy file. It's in a tab. Hopefully this will work. Okay. It'll kind of work. So just a quick, super high level example. We're just going to ignore below the blue line for now. The first 4 or 5 lines, we have a book up top. It's just a way of defining a book. A book has what you would think it has. It has a title, some pages, whatever we want to put it, an author. That's how you would kind of define it and work with it. It's an object. An object is a thing, a person, place, noun, something like that. So we have this book concept in our code. We have a library.
We call them records.
There you go. And so we have libraries. Libraries contain books, right? So some of the things you can do with the library is you can add books into the library, and you have a catalog that will, maybe show you what the books are. So the top part, we create a book, we create a library, and these are going to interact in our program if we were to write it. So down at this point, so the first part was more about kind of defining our world, things we're going to deal with. This part right here is about actually using it. So you define your code, and then someplace you're going to actually execute the code. So ignore that part. So what we're doing is we're going to create a new library. Up here, we're going to create 2 books, Stephen King, Clive Barker, Salem Slot, whatever. So we have 2 references. This is like algebra where x equals 1 and 2. A variable is just, it's like x in an algebraic notation. So now we have this book 1, book 2, like x and y or something like that. But it hangs around, it's in memory if you're not familiar with that. Now, the book 1 represents all the stuff I wrote, which the book comes from up top where we defined it, and we're adding author. Up top is author, title, and so on and so forth. And we add it to our library. So we created a library. We had 2 books. So we're adding a book, adding another book, and then we're going to call the catalog on it, which is going to go through each of the books and print out some information about it. So that's just kind of in a nutshell what it kind of looks like to write a little bit of Groovy. In Java, a lot different, or not a lot different, but a bit different. So I knew somebody here would do Fibonacci, and somebody did. And so this is the Groovy version. I really liked, you did Python. Yours was cleaner and better.
I got it from Rosetta Code.
So did I. So Rosetta Code's really cool. You can compare and contrast the same problem in different languages and just see it's not how the language works, it's how smart the person that coded in that language worked. So you'll look at some examples and say, I would have done it differently. So this is what they decided to do. I'm not going to go into it. It's very terse. If you ever wrote code like this on my project, I'd probably get really angry. But this is using enclosure, and it's using ternaries, which a lot of people hate. In this case, they're rightful to hate it because this is horrible. 2 ternaries embedded in each other. So forget that. Don't need to know that. But over here you have rfib, which refer back to this rfib that I'm defining. It's really weird. It's all inside and out, but it's called recursive, where you call the thing that's being called calls itself again and again and again. It's, I don't know, like the Russian dolls, you open it up and you have another one and so on. I don't know, maybe like that. Or maybe falling through a mirror and another mirror, or when you put two mirrors next to each other. So if I blew that out right there into like normal code, it would look a little nicer like this. So you can kind of read it. This is just a different example of it. It's all indented weird. But we're not going to look into that too much. This is an alternative way of doing it. So there's an iterative way. So you go around and around and around. You do it once, you do it twice, you do it 3 times. It's called looping. And it's still ugly. Don't write code like that. And then how we would actually, that's just defining it. Remember I said earlier, we talked about defining. Now we want to execute it. So this is the line that would actually execute both of those, the top and the bottom one, and gives us some output. Not terribly exciting. Another quick example, 99 bottles of beer. So this part is the song portion. So this is just printing out a string, and it's whatever this mess is right here of bottles of beer on the wall, blah, 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 of beer. Take one down, pass it around. You know, we all know the song. But it's got this funny bottles thing here. And so I talked about groovy strings. I catch myself on that. Groovy strings. Yeah, we get one.
String interpolation means closures.
Yeah, so this right here actually means something. So it's not going to print that. It's actually going to go, this is a variable or a method or something that it knows it's got to go figure out. So it's going to go find that. And we define it up here with this closure with some code in it. And basically what it's going to do is it's going to iterate through and figure out when we're at the end. It's going to do some tests. When we get down to 0, it's going to print no more. If we have 1, we're not going to print the S. But basically it creates a small tiny string that's going to be embedded in here. And this is a little loop. We start at 99. So the cool thing in some of these languages is everything is a object. In Java and some other languages, you have things that are objects and things that aren't. Here, everything's pretty much an object. So my number is an object. I can do things with objects I can't do with things that aren't objects. So I can take this and I can do a loop. If you've seen regular loops, they look a little bit different. But this one, I start at 99 and I go down to 1. And then I pass in this I thing into this, and that kind of kickstarts the whole thing. But anyway, so this bottles right here is going to take that number 99, which is passed in through here, and it's going to start out 99 bottles of beer, blah, blah, blah. Then 98, 97, 96, and we get down to 1, then we drop the S for bottles, and then we get to 0, and we say no more. So that's a little example. I'm going to skip ahead to get so we can kind of end real quick, but I want to show how this simplifies code. So this is Java. Java is Groovy. Groovy is Java. If you know Java, you can jump right into Groovy, start coding away, and no difference. But this is something like this is a very simplistic class if you know how to read it. If you don't know how to read it, you're like, oh my God, what is this? This is just a real simple class called Hello. That has a name inside of it, has a couple methods that do things, and then we actually execute it here. Won't go into too much, but it's kind of hurts your eyes, right? If you're kind of new to Java, if I said, what is this thing? You're kind of looking at it, I don't know, it's void, it's public, it's new, it's new.
Static.
But none of that tells you what this thing is, right? You have no clue what this thing is doing. So let's kind of groovy it up a little bit. So the first thing we're going to do is we're going to remove what are called access modifiers. Don't need them in Groovy. So basically, we have these little things called public and private. We just drop them. So it's hard to tell because I don't have a compare before and after, but we just basically eliminated a couple lines. So let's let's do something a little better. Let's remove what are called setters, getters and setters, which are these guys. Right here. So this method and this method, it turns out you really, really, really don't need. So why are they there? I don't know. Let's get rid of them. So we get rid of them. Hey, that's a little simpler. It still looks crazy, but at least I don't have to look at as much craziness. So let's do some other stuff. So this print system out println, Chris talked about earlier. This is a special way to print things out. Ed had the
It just puts so much easier.
yeah, he had puts.
Less characters.
You know, how can I argue with that?
We can get a little better. We can drop the system out and use Println. Not as cool, but it's there, so it's a little better. So we're cleaning it up a little bit. So string interpolation, we saw that with the 99 bottles of beer, and I think with something else. So this string right here is a lot simpler than this string right here. And this is one of my pet peeves when you're writing real code and you're mixing in this and that. And basically you have a bit of string like you would see in a book or a piece of paper, something that's just there, and something that's dynamic, that's running, that has some values. And all you want to do is put, the age of the person that you're spamming in your, email or whatever it is. You just want to get that in there, but you don't want to, it's difficult. So you end up with all these pluses and
It's meal merge.
yeah, exactly. And so you don't want all these pluses and stuff. It just gets ugly. So we can do this little nifty part and just embed it straight in, and it actually looks like a string. Although this is special syntax, so this name is the same name that's up here. Whatever I set that to, this is a variable. It's like X in algebra. This will evaluate to something, and so it'll print hello, whatever name happens to be. Okay, we're getting a little better. So there's some extra noise. Semicolons, what's the semicolon for? I don't know, it doesn't help me.
So you can put a second statement on the same line.
Yeah, there you go. So it has some things, but it's in programming, we really don't need it. It's just noise. It hurts our eyes. It's an extra character to type. And when you get old and arthritic like us, you want to save your characters. What else? Semicolons, parentheses. So up here, you have this parentheses, set name. Well, why do I really have this parentheses? Technically, I don't need it. The computer's smart. It's a computer. It can figure these things out. So I can drop the parentheses. This is actually technically a little different. Just ignore that for a sec. Set name. No, that is that. But anyways, we dropped a couple of parentheses. Don't need them. Although we do need them in certain places, so you will see that.
Where's the C# guy? Gets that name.
Yeah. Okay, so we're winding down now. So this is a lot better than the original, right? So we also had some extra words, void. Anybody know what void is? Why we need it? I don't know, neither do I. So we'll just remove it. Don't need it. So we have this class. It has a name. It says hello. It prints some gobbledygook. It has some main thing and stuff. So it's kind of making a little more sense. So it turns out that, remember, you probably don't, but earlier I said it's like a scripting language. So this little part right here is kind of the weird thing. So I've got this hello string name. Okay, I kind of get that. Hello, yeah, I get it. But main, def, what? And then all this stuff. It turns out that this is just a way to bootstrap your app. Most of your code, you'll have like one or two of these in your app, usually one somewhere in there. It's just a way to kickstart things. But it's not really part of this. It has nothing to do with hello. So let's just remove it. So this is our class, nice and small, and then we moved all that code inside out. So now it looked like what we had earlier, where we defined something, and then we go and actually use it. So to finish this whole thing off, well, pretty much to finish this whole thing off, we have the class hello with the name, and we say hello with that name, and we print it on the line. A little bit easier to read than Java, right? And then we call it by creating a new hello object. We assign the name world, so now we're going to say hello world. Granted, it's not like the one-liners we saw, but that's not bad. Now the last thing, how much code would it take to hit a database, define your database, your connection to the database, grab a whole bunch of data out of the database, turn it into XML, and save that out to your file on your hard drive?
150 lines.
All right, there we go.
25.
Ooh. So this was originally set up to be 25 lines, just to make it easy to read and whatnot. But it kind of started out with this little bit of code, which is exactly, well, it's 26, and I miss.
It's okay, you have extra lines.
Yeah. Well, actually, my SQL statement is multi-line, so I could have actually made it a lot shorter. But anyways. Just super quick, don't want to get into this whole thing, but it's powerful. You can do a lot of stuff in a short amount of lines. I define my connection to the database. I have my actual SQL, how I get the data out of the database. I have my SQL script on multiple lines. This is a special string that allows me to do this. I create a file. This can get like real tedious in some languages, like C, which we're not talking about, would be horrid. And we're writing it out as an XML. And this is what creates our XML. I have this little XML thing that I've read in, and I go through each row and I just basically build the XML. But very powerful, very small amount of lines of code. Groovy is really cool if you really want to kind of get started. It may not be the easiest language to ease into. Ruby would be like really, really good. This would be probably a close second, except you have to kind of set up the Java environment, which is but if you're in Java and you want to get into some of the newer cool stuff, the dynamic side of coding, some really neat stuff, Groovy is definitely a way to go. Or if you are, coding in it and you just want some to ease your pain a little bit. So that's all I got.
And for starting out, which book would you lead them to?
Oh, super quick. These are all old books. Most of them have been updated, but A-Press has some several Groovy ones. This is Groovy and Grails, which goes into web development. Groovy Recipes is not discontinued, but they haven't created a new one. It's old, but it's awesome. It's got some really, really good information. The author is a hoot. He's great. So great book. It's not up to date, but most of it's still pretty good. And then they have a up-to-date Groovy in Action. But the website's actually, oh yeah, and then Tim brought in another one, using it right here. And this is probably a much more hardcore, like let's get to the meat of it and whatnot. And this is probably for a serious programmer. This is probably definitely the way to go. This guy is a really, really good speaker. So
Groovy in Action is probably the best one to start with if you're a beginner.
yeah, they'll walk you through beginning all the way through.
And actually, they're just finishing. I think it's now going to presses. It's a book that's been going, 7 years?
Yeah,
They've
something like
been
that.
working on it. But anyway, the second edition is now coming to presses.
And with Groovy and all these languages, go to YouTube, Google the language, and like intro, beginning, easy into. If you already know a language, Groovy for Java developers, Groovy for JavaScript developers, whatever. And that'll be a good place to start.
Tom, Cameron?
Okay. Hey, thanks, Tom.
So this is Scala by Corey Minter.
So
Talking about Scala.
thanks for 5 minutes like everybody else.
Yeah.
So,
exactly.
So thanks for sticking around. Nice thing. One of the bad things about being at the end is probably everybody's really tired and wants to fall asleep. But the nice thing is there's a lot of introduction to some of the concepts coming from everybody else. So I can kind of refer back to what other people talked about a little bit. So Scala is another one of these languages on the JVM, and its main point of the language is it unifies object-oriented programming and functional programming, and you've actually seen both of those in different languages, even if it's in Groovy and Ruby and Python, all these. And its goal, claimed by the author, is it's a scalable language and it's a modular language. And it was influenced by many of the languages that you've already seen. So it's influenced by Java, SML, Ruby, Smalltalk, Haskell, and a bunch of other ones. And so, it had the benefit of learning from those languages. It's like some of the other languages, it's general purpose. You can use it for client and server applications. Some examples of, you can do web apps in these framework called Play, Lift. People build, I think like Netflix runs on some Scala stuff, yeah, and some other companies. But you can build large reactive concurrent message driven apps. You can people are doing, if you've heard of Spark, cluster computing. You know, you can do anything, except for you can, and now you can actually compile it to JavaScript. So you can check that off and one of its guesses. So if you want to run it, yep, you're in the club. So the main concepts are some of the things that you've heard already, and maybe some different things. So I'll try to kind of point out the difference. So it's a statically typed language, you know, kind of like Java that was mentioned, and some of the other ones that have optionally static type. This is something you didn't hear. It has this idea of universal nesting. So it kind of moves away from Java, and it's kind of, one way I like to think about it, it sort of cleans up what Java could be, and so it kind of changes the way that you define functions and you access variables, and it creates this uniform way of looking at it, so that when you look at it from the outside of an object, you might be calling a method, you might be just accessing a field, but it unifies all that. And the nesting allows you to, well, I'll talk about the advantages on the next page. But second thing that is emphasized by, say, Clojure is it emphasizes doing things immutable. It emphasizes using immutable data types and immutable collections. And that's really important when you want to scale something up. You want to do things with immutable data as much as possible, because it allows you to do concurrency and know what's going to happen, and know it's not going to interfere with other things without going through all these other hoops to sort of enforce concurrency after the fact with locks and things like that. And like some of the other languages, it has closures, which allows you to. I won't be able to go into much detail, but one of the things that wasn't mentioned, it has this thing called type enrichment and implicits, and that's actually one of the keys to making the language kind of different from others, in that you can actually get really succinct, higher level language with the same power, and it all still is strongly type checked. So if you want to do something with a string, you can apply methods, and it might look like Ruby or something like that, but really what it is strongly typed, and it's not dynamic at runtime, but you can do similar things that look the same. So basic. Oh, and then the last thing I want to mention is because it's built on the JVM, it has access to the Java libraries and things similar that we mentioned with other languages. So kind of the benefits of all that are type safety. And I think as an introduction to all these languages, you're going to have to, it's worth looking at a few languages to play around with and see why that's important. And it is important for some applications in some domains, I think. And the other benefit of this language is that, I find that because of that universal nesting I mentioned, it allows you to write really concise code. You can reuse, you can define classes inside of methods. You can define objects inside of it. You can nest things, and you can actually, when you can do that, you can actually narrow the scope and declare things right where you need them, and not pollute the whole namespace in your whole app. And because of the strict type checking, it enables refactoring, and it's really hard to do refactoring in dynamic languages. It's the nature of not knowing until runtime what you're going to get. So it's another one of those things where you'll have to experiment to see why that matters. And then you've got the Java libraries you can use and the platforms that you can deploy on. You can rely on all that on the JVM. So I won't go into all these, but I just want to point out that it's a really well thought out language because of it. It's been able to be designed more than just 10 days. So sometimes that's a good thing. I mean, so to look into these things and see why these things matter in something that you want to do. So just a little example of the code. I won't go into all the detail, but kind of what I want to show is even in this the first line here, where you can define classes, and we were seeing in other languages where you have getters and setters and things like that. It's really concise. So I mean, the first line is saying that you've got this value A that you want to have, and it's not mutable, where the variable B is mutable, and those are both public, and then the C is private. So it's really concise, and there's some other examples, and take a look at these later. Here's an example of kind of the top picture is maybe something familiar that you'd see with an object-oriented. You've got some sort of maybe in Java you've got an interface, you've got a method that you have on it, you've got a couple classes that extend that class with that method, and something that you're going to do with it. Down below is kind of a different paradigm that Scala introduces, where you can create these things, and you can do things from the outside using the pattern matching, and that's not something that's been mentioned in some of the other languages. So take a look at it. It allows you to do kind of really powerful different things from other languages. And in this example, I just kind of want to show, just kind of similar to some of the other examples of here's a class, there's some array of these things, and in this case, you can iterate over this person's array, take the last name, print it out. Or let's say you filter, you want the things where the first name is greater than 3 characters, and then you want to take the born year and find the max of that. So you can do these in the other languages that you saw some of them with, but just showing you what it looks like in this language. And then the last case is just to show you a little bit of what implicits get you. And this actually is not a great example, but it just kind of shows you how you can build things up. So let's say you wanted to create a, some of the problems that you have when you're doing, say scientific calculations. You mix units, or so let's say you want to build some framework around working with numbers so that you can have units and make sure that you don't mix units that are the wrong size, like add a millimeter to a meter, or even just add lengths to distances, lengths to masses or something like that. So here's an example of doing implicits, and then what you can do at the bottom is a case where I've got, like, say, in this example, 231 millimeters plus 654 meters plus 7 kilometers, and then behind the scenes, it's all type safe, and it's working with all these classes that you've defined up ahead. So all of my references are somewhere in the slides, somewhere else.
Yes.
Yeah.
Yes.
So there's a bunch of things to look at, place to get started.
Do you want to just mention one or two? Or? I will make the slides public, so if you need to
it's just
find out more information.
Yeah.
Truthfully, Google and YouTube will get you most where you want to go. But if
you can go to scala-lang.org. Yeah. That's it.
Okay.
Thanks.
Awesome.
Steve's up again.
Okay, so I'll make mine really quick. We were going to do a quick presentation on Scratch. I think we'll probably drop that unless somebody really wants it bad. And then we'll just launch into QA, and people can stay as long as they want. But anyway, we'll go from there. But I'm going to talk very, very briefly about Kotlin. One difference between Kotlin and all the other languages you've seen tonight: Kotlin is very new. It was only conceptualized, I want to say, about 3 years ago. It is another one of these JVM languages, which means it's a Java language, like Scala, Clojure, and Groovy. So what is Kotlin? As I said, it's not even in full release yet. It's in its latest milestone release, as they call it, milestone 10. So it hasn't actually been released, quote unquote. You can certainly still use it, and there are some organizations, mostly startups, who are using it. It's being created by JetBrains, who gave away the IDE tonight. And it's an open source, so it's being it's open source, so it's being contributed by people outside of JetBrains. Influenced by now, Corey mentioned that Scala, and I think this is absolutely true. Scala was a language that was written by a very brilliant man, and he thought of all the languages out there. I think Kotlin said, how do we build a better Java? And it looked at some of the alternatives out there more or less, and that's just where it went. So it was really focused on just building a better Java. Yes, what kind of language is Kotlin? Well, it's object-oriented, of course. It has first-class function support, which sort of Groovy, Scala, JavaScript, actually, maybe C#, I'm not sure, but probably. It's got a strong type system compared to anything but Scala, I would say. And I say, wait a minute, this sounds a little like Java. Kotlin is a language that is really trying to be a replacement for Java, not necessarily in the market, but for people who need everything that Java is, simple, kind of lightweight, kind of runs everywhere. That's what Kotlin is meant to be. And anyway, I'll move on from there. Why should I use Kotlin? Well, it's fast in every regard, and lightweight. Lightweight meaning there's not a lot of extra libraries. It's a Java language, runs Java. Simple and powerful syntax. Multi-platform. You can write Kotlin code that'll run without any effort at all in Java, Android, JavaScript, less so, but yes, ting. It's got excellent Java interoperability. I'd say second only to Groovy in terms of just using them straight together, because it was meant for that. It was meant not to replace Java, just to replace Java, but to be able to work with all your old Java code. It eliminates null, mostly. And it's got excellent IDE support, second only to Java. I say sometimes because it is beta. And you could certainly argue Clojure, but that's a little bit less what I'd call a traditional IDE. And it's got language support for delegation, which I love. I'm living in Java these days, and so not having delegation completely changes the way I write programs. So, in other words, I don't use delegation in Java. So what is Kotlin good for? Android applications is actually where it's mostly being used right now, curiously enough. Games is what it's mostly being used for right now in the marketplace. Web applications, just like anything else, anything you would use Java for. So everything you've heard today, basically it can be used for everything. But because it's new, it's only being used for a few things. That turns out it's mostly Android stuff. So let's see it. Let's go back. Ding. Actually, so real quick. This is IntelliJ. So this is the.
Switch out of the Darkula theme. It might be more visible.
We won't be doing that.
Underneath preferences, they have a white background and a black background. The black one's called Darkula.
And it's pretty for everything except slides. So anyway, here's a little game that I wrote in Kotlin. Actually, this is not the one I'm going to show you, I think, at this point, because it's just a little more involved. But you'll see one thing you have here is immutability on a value you're not creating at run or at compile time that is created at runtime, and that's kind of interesting. And that is done through lazy initialization. That's kind of cool. Now, I also have a whole bunch of these just simple methods. Now, this is a game, so you have things like GL, that's OpenGL, GL clear color, GL clear, other things like render, blah, 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 blah. One thing that Kotlin has is it has, gosh, I'm going to forget the name of it, but you have functions that can just be used anywhere, and you just pull in the package. You can start using those functions. Where that's really nice is when you want to wrap some really ugly Java library and add some nice, easy functions. So I created things like GL create color, GL clear is touched. And so these are, those are static methods, right? GDX input is touched. So instead of typing that every single time, GDX this, GDX that, I just have these helper methods that you can import anywhere.
Does it do currying?
Yeah, it has support for currying.
Okay, so a lot of
That's currying.
nonsense classes with one method. I was going to mention that on Tom's thing with hello.
Yeah.
Is you turn it into a function that has the initial parameters being the things that would be in the constructor, and then you just curry them away and hand off a reference to that function, and the
Right.
class goes bye-bye. There's no class vector nonsense. It's just a function.
So moving on. I just thought I would show to you real quick. Now this is actually running Gradle, which is Groovy. But Gradle is actually not just Groovy these days. Gradle is just, if you're doing a build in Java, it ought to be Gradle. Because how dare you show Ant? How dare you put Ant on my computer? Just kidding.
If they want a job, they better.
Yeah. It is 10 years ago. Let's see. So anyway, you can build little dopey games and stuff like that. Huh? Woo! Yeah. So anyway, my only point is that it pulled in. It actually, what I think is kind of cool about Kotlin, that this was a library that was built for Java, and yet with absolutely no ceremony, I'm able to interoperate with Java, build stuff easier. It runs really fast. It builds really fast, and you can do anything with it that you can do with Java. So anyway, I think that's just Kotlin for you. So the last thing we were going to talk about is Scratch. We're going to have to hold this off to a future. What's that? Yeah, we're gonna scratch Scratch, as it turns out. Good thinking, Ed. I like that.
No, we're scratching.
We're scratching Scratch. Scratch is a visual, and actually there's a few. There's App Inventor for actually Android, which is much more complete. But what Scratch is, and you can see nothing right now, but it's a visual programming environment. So you essentially take puzzle pieces and you're able to program with it. That's pretty cool. There's another one called Snap, another one called App Inventor, which I mentioned. We'll get into that in a future talk. So,
Do we have any Scratch programmers here?
anyone ever programmed in Scratch? Yeah. All right.
There's some guys back there using it today.
Oh, yeah. It is useful for plenty of things. Be happy to answer. Any of the speakers would be happy to answer any questions anyone's got right now.
Did we wear everybody out, or?
I think we did.
I would highly recommend if anybody is interested in one of the talks or in general to just pull somebody aside and ask whatever questions. A lot of the stuff you can get on YouTube and whatnot. Some resources if you want to just general programming. If you're really new, you can go to a lot of the colleges have things online. MIT, Stanford have a lot of computer programs, whole courses online. You can watch the videos on the resource. Coursera, we talked about Khan Academy, and they vary from super complex that just blow our people, probably all our minds, to fairly easy and doable. There's plenty of resources. If you're interested in Josh, talk to Josh. If you're interested on what I need for you to be a developer or what's the whole language, just pull somebody aside and just ask away.
Thanks a lot for coming. We're going to Burgers and Brew after this, some of us. So if you want to join us, please do. We're happy to talk about anything you want. Mostly not programming. Anyway.